Hi. Today we're going to look at notes for Math 7, 8-7 on theoretical probability versus experimental probabilities. So, theoretical probability is based on known facts or characteristics. Theoretical probability, you might see the word theory, or kind of looks like the beginning of the word theory. In theory. So, you've been using theoretical probability for the past couple of days, you just haven't really recognized it. When you're figuring things out about, the probability of flipping a coin and getting heads or tails, you're using the known fact that a coin has two sides. You're also using the fact we know that we assume that all seventh graders know that a coin has two sides and that dice or number cubes have six sides. That's part of the whole we're not playing the what if game. It's not, well, what if it's a unfair coin with heads on the same side? They would tell you that if it was. What if it's a six-sided die? It's not. They would tell you if it was. So theoretical probability is what should happen. In theory. In theory, if I were to take a number cube and I were to roll that six times, in theory, I should be getting a 1, a 2, a 3, a 4, a 5, and a 6. Maybe not in that order, but in theory, I should be getting one of each side. But in reality, that's not actually what happens. You can roll the number cube six times and you can get a 6 each time. Also, super unlikely, but possible. In theory, if you were to flip a coin 10 times, in theory, you should get heads 5 and tails 5 for the 50-50. But that's not what actually happens sometimes if you do the experiment. And that is where experimental probability comes in, sounding like experiment. Experimental probability is found by repeating an experiment many times. So flipping that coin 100 times and actually recording what you get each time. Rolling the dice 50 times and recording what you're getting each time. If theoretical probability is what should happen, experimental probability is what actually happens. What actually happens or happened when you did the experiment. Also can be referred to as your relative frequency. Relative frequency just meaning how many times did that 6 show up when you rolled the dice 100 times. So again, experimental probability, what actually happens versus what should happen. So if I were to flip a coin twice, in theory, I should get heads once and tails once. But that might not be what happens. If I flip the coin twice and get heads both times, does that allow me to conclude that the probability of getting tails is 0? That I'll never get tails? It's impossible because I didn't get it twice? No. And the reason with that is because it's the same kind of thing whereas if I were to ask one child what their favorite ice cream is and they say chocolate, so I assume that everybody likes chocolate and I give chocolate ice cream to everybody. That's not how it works. I didn't ask enough people. I didn't have a large enough data set. So what this big exclamation point is kind of getting at there is the fact that as the number of trials increase, so the more times you flip the coin, the more times you roll the dice, the experimental probability approaches the theoretical. So if we're talking about flipping the coin, if I flip the coin 10 times, I might get heads 6 and tails 4. If I flip the coin 100 times, I might get heads 59 and tails 51. Sorry, 49 and 51 is what I meant to say. But the higher you increase your number by, the closer it's going to get to be 50-50 exactly. So if I were to increase that to 10,000 times, I'd be way more likely to get 5,000 heads and 5,000 tails. Although, who wants to flip a coin 10,000 times? I don't